Hey everyone, and welcome. Today, we're going to unlock some of Kotlin's functional superpowers. We're going to see how you can use these concepts to write code that's not just more powerful, but also way more concise and, honestly, just more elegant. Okay, let's dive right in.
So let me ask you something. Are you tired of writing for loops for, well, pretty much everything? You know the drill. Iterating over a list, putting an if statement inside, and then slowly building up a new list piece by piece. I mean, sure it works, but let's be honest, it can get pretty clunky and kind of hard to follow, right?
Well, what if I told you there's a much cleaner, way more expressive way to do this? A way where instead of telling the computer how to do something step by step, we can just describe what we want to get done. And the key to this whole new way of thinking, well, it's all about this one simple idea.
Okay, so the first big mental shift we need to make is this. In Kotlin, functions aren't just special commands locked away in their own little world. They can be treated just like any other piece of data. Seriously. You can pass them around, you can store them in variables, you can use them like little building blocks for your logic. And the magic tool that lets us do this is something called a lambda. You can just think of it as a little anonymous function, a function without a name. It's just this self-contained block of logic that you can toss around your code just like you would a string or a number. This is, without a doubt, the fundamental building block for everything we're about to get into.
All right, check this out. It looks super simple, right? We're just declaring a variable called add2, but its type isn't an int or a string. Its type is literally a function that takes an int and returns an int. And that bit in the curly braces, that's our lambda. It's just a tiny block of logic, now stored in a variable, ready to go whenever we need it.
Okay, so storing a function in a variable is cool and all, but where the real magic kicks in, the real power, is when we start passing these little lambdas into other functions. This is what lets us customize the behavior of another function on the fly.
And that idea right there, that brings us to what we call high-order functions. All that means is that these are functions that take other functions, like our lambdas, as parameters. And guess what? Kotlin's collections library is absolutely packed with them, and they are incredible power tools.
So, let's kick things off with a classic, filter. I mean, the name pretty much gives it away, right? You give it a list and a little rule, a lambda that returns true or false, and filter hands you back a brand new list with only the items that passed your test. Simple as that. And this is just a perfect example. We've got a list of numbers. To get only the ones divisible by 3 or 4, we just call filter and pass it our rule. And see that word it? That's just a slick Kotlin shortcut for the item we're currently looking at. So this lambda just says, is it divisible by 3 or 4? Look at that. So much cleaner than that clunky for loop and if statement we talked about, right? All right, next up in our toolkit is map. Now, if filter is all about picking things from a list, map is all about transforming them. It goes through every single item in your collection, runs your lambda on it, and then gives you back a new list of the results.
And again, just look how simple this is. We want a new list where every number is doubled. We just call map and pass it the lambda it times 2. Done. No more creating empty lists, no more looping through and adding stuff, just one single super readable line of code. Okay, now this is where things get really interesting. Because these functions aren't meant to be used all by themselves. The real power comes when you start chaining them together, passing the result of one function directly into the next to build these really complex data pipelines. But this can sometimes create a tricky situation. So let's think about this for a sec. What happens when your map function doesn't just return a single item, but a whole other list? You end up with this nested structure, a list that contains other lists, and that can be kind of awkward to work with. So how do we deal with that?
You guessed it, this is exactly what flat map is for. As you can see, if we use map to get the scores for each person, we get a list of lists. But flat map is smarter. It does the mapping part, but then it does one extra crucial step. It takes all those inner lists and just flattens them all out into one single, simple list. It's so useful.
Okay, so we've played around with the basics. Let's put these tools to the test with something a little more, well, a little more like the real world. We've got some messy, faulty data, and we need to clean it up and pull out something useful. So here's the setup. We have a map of parent names to a list of their children's ages. But hey, look closer. The data's a mess, right? We've got an age of 150, another one at -6. That's obviously not right. Our challenge is to find the average age of the kids for each parent, but only using the valid ages. And here's the solution. I mean, look at that. Isn't that just beautiful?
In one single chain, we tell the system exactly what we want. We map over the values, which are the lists of ages. For each list, we filter it to keep only the ages between 0 and 120, and then we just call average on what's left. This one line of code tells the entire story of what we want to do.
And the best part is how flexible this is. Like, what if we wanted to ask something totally different? Say, which parents have any faulty data at all? Easy, we just filter the original map. And our rule is, keep any entry where the list of ages has any element that's outside our valid range. One line, a totally different question, answered just as elegantly.
All right, we've seen how amazing these function chains are for wrangling data. Now let's add one final layer of polish. Kotlin gives us this awesome set of tools called scope functions that help us manage the objects we're working on, making our code even cleaner and, importantly, safer.
So Kotlin gives us 5 of these scope functions. They all let you run a block of code on an object. The main differences are pretty simple. First, how you refer to the object inside your code, either as it or this. And second, what the whole thing returns. Some, like apply, return the object itself, which is awesome for chaining configurations. Others, like let, return the result of whatever you did inside the Lambda.
So you might be asking, why bother with these? Well, yeah, they make your code cleaner, but the absolute killer feature, the real game changer, is null safety. By using that little question mark with let, you can write a block of code that only runs if an object is not null. It's a super elegant way to completely avoid those dreaded null pointer crashes.
You see, when you start putting all these pieces together, the lambdas, the high-order functions, the scope functions, something amazing happens. You stop just writing instructions for a computer. Your code starts to read like a narrative, a clear, step-by-step story about how your data is being transformed. It becomes so much more about the what and so much less about the tedious how.
So the next time you're about to type out another for loop, I want you to just pause for a second and ask yourself, could a chain of filter and map tell a better, clearer story here? Because with these functional superpowers, you're not just a coder anymore, you're a storyteller. So what story will you tell?